Hey guys, welcome to Intermediate Robotics Camp. My name is Shreya, and today we're going to be talking about the CAD aspect of VEX design. So just an overview of this video, we're going to be going over the basics of CAD and then make a VEX plate using Autodesk Inventor. So first off, what is CAD? CAD stands for Computer-Aided Design, and CAD modeling can be done on several platforms like Fusion 360 and SolidWorks, but today we're going to be using Autodesk Inventor because it's what most of Middleton Robotics uses to make models of the robot, different parts, and to model parts on Inventor before 3D printing them. So just some basics before we start. Inventor has three main file types: .ipt for part, .iam for assemblies, and .idw for drawings. So in part files, you can make parts using sketches and extrusions. And in assembly files, you can put together parts using constraints like mating and inserting. In drawing files, you can make 2D drawings. So for this video, we're just going to be making a part because it's pretty straightforward. But in general, when you're making a part, you start out with some kind of sketch made of shapes and lines and then extrude it, which basically means that you're turning a 2D shape into a 3D form. So these images show the progression from a sketch to extruding the sketch to a certain depth and then creating a 3D figure from it. So in VEX, the pattern on the left, which we'll refer to as our template, is used in both plates and C channels. So you can download Inventor and go along with me if you would like, but it's a super large application to download, so you just have to make sure your computer is ready for that. And if you do want to get it, get the most recent version, which is the 2021, and get the free education edition so you don't have to pay for it. And this will be mostly a demonstration of the basics of Inventor, but if you have any doubts or if you would like to learn more about Inventor in general, definitely check out the videos from CAD Camp. So before we even start CADing, we should familiarize ourselves with the diagrams of the template. So each template has a 0.18 by 0.18 square in the middle, and it also has a bigger square around it with chamfers along the corners, which I'll talk about later, and then it's extruded to a depth of 0.05 inches. And here is where you would go to download Inventor if you wanted it. Now we can actually open up Inventor and start. So first you want to open up an imperial part file, which means that you want to use inches instead of the metric system. So under templates, click the English file and then click standard inches.ipt. Again, .ipt is our file extension because we're doing a part. And then click create and it opens it up for you. Now you can click start 2D sketch and then click on the XY plane. Now we can actually start drawing our template. So I'll be using the 2-point center rectangle tool because it allows you to place your first point at the center, and I want the center to be at the origin. It just makes everything easier. And then the second point, which is this corner right here, you can just drag it out. So you place your first point at the origin and then drag it out, and then you can enter in your dimensions, which are 0.18 by 0.18. And a quick way to switch from dimension to dimension without having to like move your mouse and click it manually, you can just click the tab key on your keyboard and it switches it for you. Now I'll create another square, which is 0.5 by 0.5 around it, and click escape to escape from that tool. And now we're going to be using the chamfer tool. So it basically creates an angled surface called a chamfer between any two non-parallel lines. So it's under the 2D chamfer, because we're doing this on a 2D surface right now, is underneath the fillet. So just click chamfer and then enter in your distance, which is 0.09, as you can see on the diagram. And we're just going to be sticking with this standard option because the chamfer distance from both of these edges is the same. So now you can select both of the sides that you want to put the chamfer between, and it appears like that, and then click OK. And for the rest of them, the 0.09 dimension autofill, so you don't have to do it over and over again. So just repeat that for all of the remaining corners. Okay, so now that we're done chamfering, we can move on to extruding. So I just clicked Finish Sketch, so it exited me out of the Sketch tab. And now we have the 3D Model tab available to us, and we can click Extrude and select the figure template that we just drew, and make sure that it's highlighted in green when you're selecting it. And we wanted a depth of 0.05 inches. So after we've extruded, and this is called the view cube, by the way, you can use it to navigate around and like rotate, and then this allows you to just move. But so this is our template, and now we can use the pattern tool in Inventor, and we can start making like the VEX plate. So I'm going to click the rectangular pattern tool, which is underneath the pattern tab, and just select the template that we just made. So it should be surrounded by these dashed green lines, and then select it. And now click this orange cursor underneath the direction 1 and choose one of the sides. So one of the non-angled sides. So I'm going to do this one just to make it easier to see. And these, the green versions of the template kind of shows you and gives you an idea of how it's going to look. So I want to make a 5x5 plate. So right now we're going in the horizontal direction because I chose a horizontal side, a horizontal facing side of the template. So that's how it looks right now, but we want these to all be snugly fit against each other. So we're going to make this distance 0.5 because the second box right here talks about the distance from this end to this end. And I'm just going to repeat that for the vertical side. So we want 5 rows, and then we also want 0.5 spacing. And then once you click OK, it just fills it in for you, and you're basically done. So you can use this VEX plate to make channels, or you can use this in an assembly. So you can save this as a part and then use it in an assembly and just use it as a plate in a robot. And what's great about making your own like VEX plate is that it's customizable in size. So if you wanted a different size, you basically just change the numbers in this browser here. So I'll show you how to do that. Just right click on this rectangular pattern right here and click Edit Feature. Now let's say I wanted an 8x4 plate. So I'm going to change this to 8 columns and then this to 4 rows. And then click OK, and then now you have a custom 8x4 VEX plate. So yeah, that's basically all for how to make a VEX plate part. Thanks for watching. Bye.